So in this problem, we're being asked to consider when a rigid body is rotating about a fixed axis. And we're being asked, when is it that all points in the body have the same linear displacement, angular acceleration, tangential speed, or centripetal acceleration? So I'm going to write the things that I do know remain the same for all points. So we do know that the change in theta is the same throughout all points. So let me just put here things that are the same. We also know that the angular acceleration is the same at all points because the angular acceleration depends on the change in theta and the time. So this remains the same throughout. And another thing that we do know is not the same is the centripetal acceleration. So we can take that out immediately. Because the centripetal acceleration, it's equal to the final velocity over r, and then that's equal to the angular velocity squared times the radius squared over the radius. And then that leaves us with angular acceleration squared and the radius squared. So since the centripetal acceleration all depends on the radius, it actually is different. And it's never the same on a body that rotates about a fixed axis. The other thing that we don't know, that we know is not the same at all points, is the tangential acceleration. So we can also get rid of that, and that goes along with the tangential speed. So the tangential acceleration is not the same at all because the radius can be different. It's like this, and again, it's another equation that depends on the radius, so it's not going to be the same. And then the other thing that we do know, we know that this value will be the same at all points. Same at all points. So we automatically know that the angular acceleration is the answer because that is what remains the same at all points in the body. The linear displacement is also not the same at all points in the body because there's always going to be a different distance when you have a different point.